Learning target 2.4. I know electronegativity and ionization energy increases left to right across a period and up a row. All right, let's go ahead and start with electronegativity. Okay, so seriously, this is probably the easiest way to think about electronegativity. Equate that with the sexiness of an atom. I mean, really though, really, it's the sexiness of an atom. Here's why. The definition of electronegativity, as you guys already know, is the ability for an element to attract electrons to itself. Attract to itself, right? AKA how sexy it is, right? The sexier you are, the more electrons you attract towards yourself. Okay, now, how do you determine whether or not something is electronegative? It all comes back to the atomic size, right? So the way you think of atomic size is you think of its atomic radius, right? How large it is. So as a reminder, here's my periodic table. Okay, so as a reminder, atomic size, AR, or radius, is big here, and atomic radius, or atomic size, is small here. Okay, so turns out that your most electronegative elements, or atoms, are also going to be really small, right? And this turns out that the smallest atoms tend to be the sexiest. Not to be a hater or anything, but come on, if it's like 70 degrees outside and you had to pick between a guy or girl wearing 15 layers of clothes and looking crazy, or a guy or girl who's wearing just like 2 layers of clothing and looking kind of not crazy, then you'd probably choose the one who's wearing less, right? The one who's smaller. Okay, now small is sexy, so think of it that way. Whatever the analogy you want to use, just remember that the smaller the size, the more electronegativity it has. Okay, so the real reason is because the smaller you are, the more control you have. So small equals more control. Okay, and that's, again, control has to do with the size, right? So if your highest electronegative, the electronegativity is high up here, so high En, and because this is where your largest atoms and and elements are, then it's low electronegativity here. So it's literally the opposite of atomic radius. Okay. Now the only exception for electronegativity is this group right here. It has no electronegativity. What group is this? This is group 8 or 18, or your noble gases. This has no electronegativity because it has no ability to attract electrons. It already has a full valence shell, right? So it's not going to be able to take any more electrons. So no electronegativity, noble gases. So your element with the highest electronegativity value is going to be fluorine. Okay, now they're too cool. Let's see. The other part of this, electronegativity, is ionization energy. And ionization energy is similar. It's the same trend. Okay. Ionization energy is the ability to lose an electron. Okay. Now, it is, I don't have any fancy way of remembering that, but there's different values of ionization energy. We're just going to focus on the first ionization energy. Okay, now, the interesting thing about this is if you have high IE, that just means it's hard to lose an electron. Hard to lose. And if you have low IE, it's easy to lose. your electrons. Okay, so this is actually really key. So if you have a high IE, it's hard to lose an electron. Looking at your periodic table, thinking about size, right? Which part is going to have the high ionization energy? It's going to be over here, right? You have the highest ionization energy in group 18. It's really hard to lose an electron from something that is holding it really tightly, from something that's really tiny. Whereas down here, it's really easy to lose your electron, right? And this does include your noble gases. Really, really hard to pull an electron away from someone who's very happy and stable. Whereas, think about it, you're huge, you're large, you're wearing 15 layers of clothing. If someone steals your iPhone out of your pocket and you have 15 layers on, would you even notice? No. It's really easy to lose stuff if you're really large. Okay, so in summary, ionization energy and electronegativity have the same trend, right? Same trend, low and high, here, right? Lowest on the lower left, highest on the upper right. The exception is no electronegativity for your noble gases because they don't care about other electrons. Okay, so given all of this crazy business going on here, let's go ahead and take a look at a practice question. The question is, and go ahead and write this down, which of the following elements has the highest electronegativity? Okay, so I'm imagining my, oh, that was bad. My periodic table. I know highest electronegativity is when it's the smallest. So my smallest ones are here. So I'm going to look for things that are up here. Highest electronegativity are going to be down here because down here they're large, so it's not going to help me. Okay, which of the following elements has the highest electronegativity? Now I just go ahead and look at my periodic table to see where everything is. Okay, potassium, lithium, chlorine, oxygen. Here's potassium, number 19, lithium, chlorine, and oxygen. Okay, so the one that's going to be highest, while it's not potassium, it's not lithium, it's going to be between one of these two. Right? Turns out the answer is oxygen that has the highest electronegativity value. Right? Now you may be wondering, why not chlorine? Chlorine's right next to fluorine, just like oxygen is. But think about size, right? Which one is going to be smaller, oxygen or chlorine? It's going to be oxygen, right? It has less protons, it has less electrons. Chlorine, more shielding compared to oxygen. It's going to be slightly fatter. So oxygen is going to be the smallest, therefore it's going to also have the highest electronegativity.